Okay, so hopefully everyone can see my screen. So today, this is actually session number 3. I got session number 2 on there, but this is corridor modeling. And today we're going to be talking about defining and reviewing super elevation. We're going to take a look at reviewing our template library, and we're going to learn how to create a corridor for our project. So we're going to create some multiple template drops, define point controls for our super elevation and our transition vertical alignments. We're going to define corridor references to create our lane widening, define some parametric constraints, and then we're ultimately going to review our cross sections in our 3D model. So if we take a look at what we did the previous week, previous session that is, last week we created the horizontal and vertical geometry for our Highway 72 project here. So on my screen, you can see I have my horizontal geometry up here, the top for Highway 72, and then down below here is my profile information for Highway 72. Now the profile that we're using was the westbound profile grade line. So we're using that for most of the project. That's going to be used for both sides of the road, eastbound and westbound side. We also have some transitional profiles here in the beginning and ending of the project that will bring us back down to match existing for both sides of the roadway. So that's what we did last week. We created that geometry, and we'll be using that geometry this week to define our super elevation as well as our corridor. So hopefully everybody saw the session last week. So let me go over here. I'm going to open up the completed version of our corridor so I can show you where we're going with this today. We should be able to do all this in the time that we have. Okay, so our completed corridor model kind of looks like this. We're going to put in some multiple template drops, assign our super elevation, and we're ultimately going to create the 3D model and take a look at our cross sections as well. So our finished 3D model is pretty much going to kind of look like this. We'll have our tapers in the beginning of our project where we have our lane widening, got our median ditches and our side slope grading on the outsides. We'll have some approach slab templates that we'll put in, some bridge templates, and then again the transitional area at the beginning and the end of the project. So this is kind of what it should look like when we're all said and done at the end of the day. So I'm going to show you how to create all this from scratch, hopefully in the time that we have today. So the first thing we're going to start off with is defining our super elevation. Okay, so to create super elevation, you need to create super elevation in a 2D file. Okay, so I'm going to create a brand new 2D file, and we're going to store our super elevation information in that file. Because recall, everything that we're doing in OpenRoads Designer, all the information is being stored in the design file, in the DGN file. It's not being stored in external files outside of the software. Okay, everything's stored inside of the DGN file. So just want to make sure everyone's clear about that. Okay, so let's first start off. Make sure that you're in the software. Make sure you're in the training and examples workspace, and you're using the training imperial work set. Okay, so that's what I'm working in right now. So I'm going to create a brand new file from scratch. I'm going to go select new. Okay, and I'm going to navigate to my session 3 data. Make sure you have the data set for this if you're going to follow along with us. So I'm in the session 3 data folder. And notice I have this broken up into various disciplines and whatnot. So we're going to be working in the super elevation folder. So the first thing I'm going to do is I'm going to create a brand new file to store my super elevation information in. Okay, so you want to make sure you select new, go to the super folder. That's going to bring up the create new file dialog box here. And you want to make sure you select the proper seed file, because it's going to set our working units and our coordinate system and whatnot. And make sure you're using the seed Highway 72 seed 2D DGN file that's located in our seed folder. Okay, so make sure that's set as so. And then for our file name for this super elevation file, we're just going to key in Highway 72 underbar SE mainline. So all the super elevation for our mainline corridor is going to be stored in this 2D DGN file. Okay, so I'm going to go ahead and click Save. and it's going to create that file for us. Okay, so this is just going to be a blank file that we're starting with. Again, we're working in 2D, so I just want to make sure we're clear about that. Now the first thing we want to do is we want to reference in our horizontal geometry, or our horizontal alignment for Highway 72. So to do that, we need to go to our reference tools. So to get to the reference tools, we want to go to, make sure you're in the Open Roads modeling workflow here. Okay, we have many workflows here that change the tools on the ribbon. We're going to select the Open Roads modeling workflow, go to the Home tab, and then I'm going to come over here to my primary panel on the ribbon, and I'm going to select references. So now at this point, what we're going to do is we want to reference in our centerline alignment, or our horizontal alignment. So I'm going to go up to Tools, Attach, and we're going to navigate over to my Geometry folder. Make sure you're in the Session 3 Data Geometry, and select the Highway 72 Geometry Centerline Design file. Okay. We want to set the attachment method to interactive so we can review some of the reference file properties and settings. So let's make sure we select that, select the attachment method there, and then go ahead and open the file. So I'm going to open that up. You'll see it's going to load the default model up here. I want to set the view orientation to coincident world. All the settings down here just leave as is, and then we're going to click OK. It's going to attach the file to the design file, and now at this point you can simply close the references file. Now let's go ahead and fit our view. So in the View 1 window here, we'll select the Fit View button. So I'm going to go ahead and view that. Now you can see here's our horizontal geometry. So you can see the horizontal geometry is made up of a tangent, curve, tangent, curve, tangent. So we need this in order to calculate our super elevation. We need to have our geometry in there so we can get our curve data and all that good stuff from when we calculate our super. Okay. So now the next thing to do is we need to define the limits of our super elevation. And to define the limits along the alignment here, we have to create what we call a super elevation section. Okay, so to create the super elevation section, we want to go to the Corridors tab. So I'm going to select the corridors. You'll notice we have a set of super elevation tools over here, and we want to create a super elevation section along the length of our alignment here. So I'm going to select Create Super Elevation Sections, and then I'm going to key in a name. You can give us whatever name you want. I'm just going to call it Super Highway 72. It's just going to be the name of my section. I'm going to left click to accept that name. Now I'm going to be prompted to locate my corridor or my alignment. So let's go ahead and select the alignment. You'll notice it's called Highway 72, and it's being referenced from the Highway 72 Geometry Centerline Design file. So we select that. Now at this point, we need to define the start and end station. Notice there's a shortcut key on there. It says Alt, lock to start. So I'm going to press Alt on the keyboard, ALT on the keyboard. It's going to lock it to the start station, which is 500 plus 00. And then to the end, we're just going to press Alt on the keyboard again to get to the end. And we're going to left click to accept that. Now at this point, you're going to be prompted to enter the minimum tangent length between curves. Okay, now if you have multiple design speeds on your project, you may want to create multiple sections along your alignment. In our case, our design speed is 70 miles an hour for the whole project. So we're just going to create one section along our alignment. We're not going to create multiple sections for each curve or each curve set. So I'm going to set this value to a large number so we just end up with one singular section along our alignment. So I'm just going to key in 10,000 there and just left click to accept that. Okay. Now at this point, it's going to be prompting you to create lanes. Now I'm not going to start creating lanes just yet. I want to review the super section information here. Okay, so you can see this shape here. This represents our super section. If we select that and hover our cursor over it, you can see we have access to some of the other super elevation tools here. And we can also review the properties of that super elevation section. So you can see there's the name of that super elevation section, the feature definition that I use, the start and the end station. Okay, so now the next thing we need to do is we need to define our lanes for our project. Okay, the lanes are used to apply our transitions, our stations and cross slopes to the lanes. And also going to control how the corridor is going to behave when we go to apply super elevation to the corridor later. So what I'm going to do here is we have a couple tools for creating the lanes. You can create the lanes manually, and generally the lanes are created with just horizontal offsets. But what I'm going to do is I'm going to streamline the process a little bit. I'm going to create the super elevations by utilizing a road template. Okay, so I'm going to navigate over here into my template library, and we can take a look at the templates that we're going to use on our divided highway project. Okay, recall that this is a widening project. Okay, so I'm going to go and open up my template library for this project. So I'm going to navigate over to my templates folder. Now, I already have my template built. All my templates are built for this project. We're not going to be creating any templates from scratch or anything. So my normal section of pavement, my normal typical section or template, kind of looks like this. We have 3 pavement lanes on each side. And at the beginning of the project where we transition, we have 2 pavement lanes. So we're going to be widening to the inside, so we're going to be adding a 3rd lane on the inside here. Okay. Now when we go to calculate our super elevation, the super elevation gets flagged in the template. So when we go to create our corridor, we'll assign the transitions and cross slopes to our template. Okay. There are special flags set up on these templates to tell it which points are going to be flagged for super elevation. So if I come over to the active template here, if you want to know which points are going to be rotated or transitioned in terms of super elevation, we can just go to the active template tool, select super elevation. You can see all the points there that are going to be defined with super elevation. Okay. Now also, if I double click on any of these points, you can see there's a special flag inside of the actual template that defines which points are going to be used for super elevation purposes. Okay. So these are the templates that I'm going to be using for the project. So to define the lane widths or super elevation lanes, we're just going to grab one of these templates so it can build our lanes for us, and then we're going to calculate our super elevation transitions. Okay. So let me close down the template library there. Okay, so the next step is create our lanes. We're going to create our lanes from that template that I just showed you. So it's going to prompt you to locate the super elevation section. So again, I'm using create super elevation lanes by road template. Okay, that's the tool that I'm in. Okay, so I'm going to locate my super elevation section. Right click through the prompts. Now at this point I can press Alt down to browse into my template library and pick the template that I want to create my lanes with. So I'm going to select the 6 lanes, inside edge, PGL, click OK, and then I'm going to left click through the prompts. And that's going to go ahead and define our lanes. Okay, now right now it doesn't really look like it did much. It drew some graphics in here, but what I'm going to go ahead and do is turn on my fill. Oops. And then you can see the various lanes that have been created. Okay, now each lane has a specific name, and that name relates back to the points that you saw in the template. So you can see here that this is the right outside lane on the eastbound side of the road. That particular lane is called CO underbar R and E-EOP underbar R. Okay, so those relate to the template points that you saw in my template. So that's the naming system there. Okay, now the whole purpose of the lanes is the lanes are going to function as kind of a container or a storage place for the transitions. Okay, so when you calculate your super or you create the super manually, you have to have these lanes here. Okay, you have to have these lanes so it can store the stations and the cross slopes on these lanes. Okay, because it's going to get related back to the corridor later. So let's go ahead and calculate our super. Okay, so at this point, I'm going to come over to my calculate tools, and when you go to do the calculations, you want to take a look at the super elevation rule file. Okay, so generally we deliver a couple super elevation rule files, and this has all your typical AASHTO tables and equations and some other preferences in that file that's going to help with calculating your super elevation transition. So I'm going to go ahead and open up the one that I have in my training folder here, or in my session 3 data folder. So let me go over to session 3 data. Go to super, and this is the same AASHTO 2018 table that we deliver with the software. I just copied it and placed it over here in this folder so we could get to it fairly quickly. Okay, so I'm going to load that up. You'll notice that the dialog changes a little bit, has some of our settings that we want to use, and if you need to make changes to the XML file, this rules file, you can do that directly in this dialog box here. You want to change the percent on tangent, adjust for curve overlaps, and some of these other things. You can do that in here. I'm just going to leave mine set for these default values. On my project, I already have my design speed set for 70 miles an hour. We want to make sure our pivot method, we're going to be rotating about the inside edge. So we're going to be rotating about the inside edge on the PGL for the eastbound and westbound side of our road. And our runoff length method, we're going to set to AASHTO relative gradient. Our Emax is going to be 8%. So this is going to be our default values. And you'll see how that comes into play here shortly. These are the rules. This rules file basically defines how the super elevation is going to be calculated. Okay, so I'm going to go ahead and just save that real quick. And we'll close this down. And then what we'll do is we'll come over here to the Calculate Super Elevation button and actually create the transitions. Okay, so now by default, you'll notice that the rules file is loaded automatically. It's also loading up those default values that you saw in the dialog. So let's go ahead and locate our first super elevation section. So I'm just going to come in here and select it, right click to complete, and then I'm just going to left click through the prompts. And then now at this point, it's going to go ahead and apply the calculations to the lanes. Okay, so now there's our super elevation transitions have been calculated. You'll notice the colors change, indicating the various transitions throughout the project. And now if I click on one of the lanes, you'll actually see I have stations and cross slopes here throughout the project. Okay, so those are all my super elevation transitions that I calculated, and those are now assigned to each one of my lanes. Okay, so now this is just a plan view that we're looking at here. Okay, so if you're used to doing super elevation and more of a super elevation type of diagram, we can do that as well. So if you want to review the super elevation information in more of a super elevation diagram, we can open up our super elevation view here. So I'm going to go over here to my super elevation panel on the ribbon. So we've got the special tool here called Open Super Elevation View. That's going to allow us to see the super elevation diagram information that is related back to these lanes that you see in the 2D plan view. Okay, so I'm going to select and locate my super elevation section. So I'm over here, selecting this tool, Open Super Elevation View. I'm going to select it. I can select any of these 8 views at the bottom of the screen. Just pick one. I'm going to pick number 5. It's going to open up view 5, and then you're going to left click data point inside of that view, and it's going to show you the super elevation diagram. Okay, so these are all your super elevation transitions. Okay, so each one of those lanes has a separate control line or a separate super elevation diagram in here. Okay, so if you need to make changes, we can make changes here, and you can see there's some dynamic text in here. We can click on the dynamic text. We can modify the stations and cross slopes. If we want to just work on each lane at a time, if we right click in the view, we can select lanes to display, and we can select any lane that we want, and we can work on it here if we need to. Okay, so if we want to make changes, we can make changes here to our stations and cross slopes, or we could come back over into the plan view, and you can see we have some text drawn here. We got our station text. We can click directly on that, make a change there. We can click on our cross slope values. We can make changes there. So there's many ways we can make edits to the super elevation information. Okay, so I'm going to go back in my super elevation view and toggle back all my lanes back on there. Okay, so this is a special managed model inside of the software. Okay, this super elevation view here. So it's very important to understand that there's rules and relationships that exist between this plan view and this super elevation view. Okay, so if you delete all these super elevation lines here, all your lanes are going to disappear. So be careful of that when you're modifying information over here in the super elevation view. Okay, so at this point, I want to have a poll question up and see if you guys can answer it for me. I know a lot of people typically probably calculate super elevation in a spreadsheet as opposed to letting our software give you the answer. So we just want to get a quick poll and see how many people, which method that you guys use. I suspect most people are doing super elevation in a spreadsheet, and they typically will input it manually or import it from a CSV file or whatnot. Okay, so it looks like, just as I suspected, there's a lot of people that do import it or calculate it in a spreadsheet. So I want to spend just a couple minutes here showing real quickly, if you want to get your super elevation information in here from a spreadsheet, how we can do that real quick. Generally what we'll do sometimes is we'll let OpenRoads kind of calculate the first run of super elevation, and then what we'll do is we'll go into our reports here, and let me select my section, go into my reporting tool, super elevation report. This will open up a bunch of various style sheets where we can get reports on our super elevation. So the default report looks like this: super elevation data. It's going to show you the rules file that you use, your design speed, and your other super elevation design criteria. This one's pretty useful. Now, one that you're going to find really useful is this one here, super elevation to CSV. So if you have a spreadsheet where you already have your super elevation calculations set up in, what you could do is you could take this file, save it as a CSV file, open it up in Excel, and change all the numbers, and then import the information back to the software. Okay, so I just want to show you how to do that real quick for those people that like to do the spreadsheet thing. So I'm just going to come in here and type in super there and set the file type to save as. Okay, so what I'm doing here is I'm selecting my super elevation to CSV. I'm going to go up to file. I'm going to just do save as. I'm going to set that to text, and we're just going to key in a name here, call it whatever you want. Okay, I'm going to save this off. And then what it's going to do is it's going to create the CSV file. It has to be in this specific format in order to be read back into the software. Okay, so if we go take a look at that CSV file. Okay, actually I named it wrong. I should have named it CSV, but that's okay. Just do that there. That should be good. Open that up in Excel. Take a look at it. And now in here, inside of your spreadsheet, you can go in and you can make changes to your stations and your cross-slopes. So this is kind of the basic format. What you see over here is the name of each lane. What you hear is the station, the cross-slope, the side of the road, and then the normal crown, reverse crown, full super, and whatnot. That's pretty much the basic format you need is pretty much this right here. Some of this other stuff you don't really need. But if you do need to want to bring it in, have a need to bring it in from a spreadsheet, this is how you do it. Just get it in this format, okay? And once it's in that format, what we can go ahead and do is we can get rid of these calculations, okay? And a way to get rid of those is we'll go into our super elevation editor, which is another way to review our information in a more tabular format. Okay, so this will load up our super elevation information in more of a table, okay, and a graphical view up to the top here. And what I'm going to do here is I'm going to clear this out. I'm going to delete all this information. This will get rid of all the super elevation transitions from our lanes. Okay, it'll keep the lanes intact, keep our super section intact, but it's going to get rid of our calculations for us. Now, if we want to overwrite those, we're going to come back in and go to import super elevation. We're going to locate our section. We're going to go back to that super elevation file. Okay, we're going to write that back in here. Okay, it's going to rebuild the diagram for us, and it's going to apply any of those new super elevation numbers that you may have changed from your spreadsheet. So it's pretty much how we do super, and that's what I'm going to use for the remainder of our project. Okay, so to check some things here just to make sure everything's still set up right before I go on to creating our corridor. Looks like we're good. So I want to make sure nothing got changed drastically when I did that import there. Okay, so we're good. So now hopefully that's it's kind of a fast-paced look at how you do super elevation in the software. So the next step, we want to start talking about some corridor modeling. So I'm going to spend the rest of the time creating our corridor. Okay, so let's go over and create a brand new file now. So I'm going to go up to File, click on New. I'm going to go over to our Corridors folder. And once again, we're going to create a brand new file, brand new 2D file. We're going to be using that same seed file that we used previously, Highway 72 underbar seed 2D. That's located in the seed folder for session 3 data. Okay, so let's go over here and give it a name, Highway 72. Call it mainline. It's going to be the name of our corridor, and it's going to live inside of this folder. Okay, so let's go ahead and save that so it creates that brand new file for us. Okay, so we've got a brand new blank 2D DGN file. Now we need to reference in the files that we need for corridor modeling. Okay, so we're going to need a bunch of files to start the process. We need to reference in some files here. So we're going to need our geometry files. We're going to need our terrain model. We're going to need our super elevation file. Okay, so what I'm going to do is I'm going to go back up to my home tab. I go to my reference attached tools here. Go to references. I'm going to open up my Explorer, and this time I'm just going to drag and drop files into the reference window just to save a little bit of time here. So first thing I'm going to do is actually go down to my terrain model folder, grab our existing terrain model. I'm just going to drag and drop that into the window here. It's going to ask us for our attachment method. I'm going to set the attachment method to coincident world. I'm going to click OK. That's going to attach our terrain model. Now I'm going to go back up to my geometry folder where I have my geometry and I have my proposed horizontal layout files. So I'm going to grab both of those. I'm going to drag and drop those into my reference tool here and click OK. It's going to attach those. And then I'm going to go and grab my super elevation file that I just created previously. We're going to drop that into the window as well. Okay, so now I have all the files that I need for my corridor modeling. So I have my existing ground terrain. It's going to be used as our target existing ground surface for our side slopes and end conditions. So we have to have that. We have our horizontal and vertical geometry is inside of our geometry centerline file. So we need that. Some of our transitional pavement and edges of pavement horizontal geometry are in this file. We're going to use that for some of our tapers. And then, of course, our super elevation is in this file. Okay. Now at this point, we're going to close this down and then we're going to fit our view. So a view one window here, we'll just go over to the fit view and you can see the files have been attached. Okay, now at this point, again, we're working in a 2D file. But notice we attached a 3D file. The 3D file was the existing terrain model. I'm going to take a look at our models here. We can have multiple models inside of a 2D file. We can have 2D and 3D models inside of a 2D file. So I want to briefly show that and how that works. It's a very important concept to understand when you're working with the software. So I'm going to come over here to my primary panel. So you go to the Home tab under Primary. We're going to go to Models, and you're going to see here we have the default 2D model. Okay, now we also have the terrain model boundary that's been referenced in, or the terrain model that's been referenced in. That is a 3D, that's a 3D DGN file or a 3D model. Okay, so when we're working with corridors, the corridor gets built in a 3D model. Okay, now for the 3D model to get built, we need to activate this existing ground terrain. So to activate this, I'm going to select the terrain model boundary. I'm going to hover my cursor over there. I'm going to select Set as Active Terrain Model. And then when you select that, notice in the Models box here, we now have a 3D model that gets created. Okay, so now we have a 2D and a 3D model. Now when we're using the corridor modeling tools, we're generally going to be working in the 2D view, and we're going to mainly be using the 3D model just for reviewing and displaying purposes. We're not really ever going to be drawing in there. Okay, so what you want to do is you let OpenRoads or let the software manage and create the 3D model. Typically don't want to be drawing stuff over there. So generally you want to be doing all your work in 2D and let OpenRoads manage and do what it needs to do with the 3D model. Okay, so that's an important concept to understand when you're working with this stuff. Okay, so now what I'm going to do is I'm going to set up a couple different views. I'm going to set up the 2D view and the 3D view so we can see what's going on before we start building the corridor. So I'm going to right click in my view. And I'm going to right click and hold down, and you can see here we have some special view shortcuts set up. So I'm going to select number 2 from the pull down. That's going to open up my 3D model view over there in view number 2. And we got my plan view here in view number 1. Okay. So now what you see here in the 3D view, I'm just going to rotate this around, go up to my view rotation tool here. Rotate that around. You can see the terrain model boundary, that's the existing ground, and then we have the 3D representation of our geometry there. So this is our 3D feature of our center line. Okay, so now what we're going to do is we're going to start creating the corridor. So how do we create the corridor? We're going to go up to the Corridors tab, and once again, before we start creating the corridor, let's quickly take a look at our template library again. So I'm going to toggle over to the Create Template tool, just so we can take a look at these templates real quickly. So beginning of our project, again, we're going to be transitioning from 2 lanes to 3 lanes because we're widening to the inside. So we got this transitional template. And then we have our full template, the lane widening on the inside. We have our approach slab, and then we have our bridge. Okay, so we're going to take these templates, we're going to drop them at a 25-foot interval along our corridor, and then the 3D model is going to get built based on the templates that you see here. Okay, so templates, if you're not familiar with them, they're made up of points and components. Components here are these closed shapes that you see. Okay, so when you drop the template along your alignment, stuff gets built and generates the 3D model for us. Okay, so we'll end up with 3D feature lines and 3D components in the 3D view, and all that's being built from these templates here. Okay, so let's go ahead and start creating the corridor. So right off the bat, I'm just going to go over to my corridor tools here, create a new corridor. It's going to prompt us to locate our baseline. You also see a dialog come up here to select a feature definition. It's going to be using a feature definition called final, and those feature definitions just control the display and accuracy of the 3D model, and these we deliver with the software, with the workspace that I'm using. Okay, so what we're going to do is we're going to locate our center line. So I'm going to come over here and locate my Highway 72 geometry. Now for our profile, we're just going to use the default active profile, which is my westbound PGL. Okay, so when it asks you for that, we're just going to right click, and then we're just going to left click through the prompts. Okay, now at this point it's going to prompt us to locate our template. Okay, so the first template I'm going to place, I'm just going to grab the normal 3-lane or 6-lane template that does the 3 lanes on both sides, just so you can see it build the corridor. And we're going to start at 505 plus 10. Okay, so that's going to be our starting station, so take a note of that. That's always going to be the starting station, 505.10. The ending station is going to be 543 plus 00. Press Enter on the keyboard to lock in those values, or press Alt on the keyboard to, press Alt on the keyboard to lock to the end, or press Enter or Tab to lock in those values. Okay, so we're using 505 plus 10 to 543. Okay. I'm going to left click through the prompts, and our template drop interval is going to be 25, so we're just going to keep 25 there. We're not using this transition, so just leave that and set it 0. That's going to go ahead and build our corridor for us. Okay, so now notice in the 3D model, we should now have our pavement, our median ditches in there, our side slopes on both sides of the road. Okay, so that's what it would look like if we were just doing one template and our project was super simple. Okay, but our project is not this simple. Okay, we have some approach slabs, we have some bridge areas, we have some lane widening and things going on up here, and at the end of the project, okay, so we're going to have to address that. But you could see all this is being built automatically in 3D. They didn't really have to do anything in 3D to make that happen. Okay, now let's address what's going on in 2D over here. So over here in the 2D view, you can see we have some additional graphics that were drawn. We have the actual corridor object. It has some graphical handlers attached to it so that you can select it easily. And if you select it and hover your cursor over it, it gives you access to some other corridor modeling tools, as well as the properties. The properties will tell you the name of the corridor and what geometry was used to create that corridor. We also have graphics for the template drop, so if you hover your cursor over that, it will tell you what template drop and the station range that was used for that template drop. If you select the template drop, it gives you access to the dynamic graphics here, where we can manually key in a different station, or we can graphically change the station using the graphic manipulators here. Okay, so many ways to make changes. Now, one other thing we need to take a note of, as you can see, we got some other graphics here showing up, kind of messes up the drawing or makes it look somewhat messy. What this is this is the 3D model being referenced into the 2D view. So what we want to do is we want to clean that up a little bit because it's not helping me right now. So I want to go ahead and go to my reference files. I'm going to turn off the 3D view here. Okay, so I'm going to toggle that off. We don't really need to see that in the 2D view for what we're doing today, so I'm just going to toggle that off. So you can just select it, Select the display button here, just turn it off. We don't need to see it right now, okay? So now the next thing I want to do is start creating our other template drops for our project. We got this transition that we need to worry about in the beginning and ending of our project. We got the approach slabs and we got the bridge area. So I got some multiple template drops I'm going to start creating. Okay, so I'm going to go back to my Corridors tab here, and we're going to be using the new template drop tool. So we're going to create template drops at different locations along our corridor here. Okay, so also notice, I have my proposed horizontal plan layout referenced in here, and I also have some graphical lines drawn in here that's going to help me place my template drops at the proper locations where some of these transitions are going to happen in relation to the widening, as well as my approach slab and my bridge area. So I drew some graphical lines in here that I'm going to just use as a guide for when I'm placing my template drops. Okay. So take a deep breath and let's get rolling here, creating some template drops. So first, let's go to New Template Drop, and we'll be prompted to locate our corridor. So I'm going to select my corridor. Now this time, in the beginning of the project, we want to use the transition template. So I'm going to use the Alt key on my keyboard, Alt, down arrow. It's going to take me into the template drop library, or into the template library. I'm going to select the Inside Edge PGL transition template. And click OK. I'm going to left click to accept, and then this one's going to go again from 505 plus 10. So key that in, press enter on the keyboard, lock in the value, left click to accept. And then I have this graphical line drawn in here for my ending station. I'm just going to snap to that. So you notice I have my snaps on here. Got my AccuSnap set to key point snap. Okay, so AccuSnap's toggled on. We're just going to snap to that endpoint here. 507 plus 75 should be the station. Template drop interval again, 25 feet. Left click through the prompts. It's going to go ahead and add that template drop to the model. And if we take a look at the 3D model view over here, you can see it adds that template. Okay, so we don't have our horizontal widening yet. We'll deal with that a little bit later. Let's get our template drops in here first, and then we'll deal with the widening later on. Okay, so we got that taken care of. Let's come down here to our approach slab and bridge area. Drop in an approach slab template here and a bridge template through this area. So again, we're utilizing the same tool, so I'm still inside the same tool. I don't need to come over here and reselect it. Just going to select the corridor again. Okay, this time I'm going to press Alt, down arrow, select the approach slab template. We'll throw that in there, and we'll left click to accept. And then now for the beginning station, I'm just going to snap. Key point snap should be 23 plus 00. And key point snap over here, 23 plus 25, because it's 25-foot approach slab. And then template drop interval, we can leave it 25. It's good enough for what we're doing. Left click through the prompts. It's going to go ahead and add that template drop. Come over here in 3D model view. You'll see it adds that approach slab. Okay. So now we're getting into the bridge area. Okay, so the bridge area, I have a simple bridge template set up here just to kind of be a placeholder for the bridge. Typically, you're probably going to use Open Bridge Modeler or something like that to model your bridge, make it a little bit more accurate. But for what we're doing here, we're going to put in just a template type of bridge using the template library. So it's going to keep rolling along here. Select my corridor. This time we're going to press Alt, down arrow, go back to the template library, select our bridge, click OK. Again, left click through the prompts. Come back here, snap to 23 plus 25, snap to 26 plus 85, left click through the prompts. Hopefully if I did everything right, we'll get a bridge. And we got our bridge in there. So now we need to do our other approach slab on the other side of the bridge. So again, we're still in the same command. So let's use the Alt down arrow to go grab the approach slab. Okay, so once again, I'm going to snap to my graphical lines here. 526 plus 85 to 527.10, 25 feet. Left click through the prompts, and we get our approach slab in there now for that side. Okay, so last part, last template drop that we need to create is back here at the end of the project where we have our lane tapers. So we're pavement has to taper back in. It needs to go back down from 3 lanes to 2 lanes on each side of the road. So we need to add in that transitional template. So I'm going to go ahead and locate my corridor. Press Alt on the keyboard. Select that transitional template. Click OK. Left click. Use my graphical line here at 540 plus 50. Ending station, again, 543 plus 00. That's our end station of our corridor. Okay, press Enter to lock in that value. And then left click to accept. Okay, so there we go. So now we have all our template drops placed. So we're good there. So we're about halfway there, right? There's still some things we need to take care of. We need to address our super elevation. We need to address the separate profiles or the separate vertical alignments, those transitional vertical alignments that we have at the beginning end of the project to get it back to grade. So we need to address that. We also need to address these tapers. So the first thing I'm going to do is let's address those vertical alignments because we need to get this thing back on grade. So let's take a look at the cross sections right now that we have this thing created. So what I'm going to do is take a look at our cross sections. So to take a look at the cross sections, I'm going to come up to the on the corridors tab here. I'm going to go over to the review tool. I'm going to say dynamic sections, open cross section view. Okay, so I'm going to select that tool. I'm going to locate my corridor. It's going to prompt me to select or open a view. I'm just going to open up view number 8. So select view number 8, left click in that view, and then you're going to see what the cross section looks like for our corridor. Also note at the top has the name of the corridor, the geometry, so there's our center line, and then the profile that's currently controlling this corridor and these templates. Okay, so right now this whole thing is following our westbound PGO profile. But notice in the beginning of our project, this needs to match existing. This needs to come up at the beginning of our project, so it needs to follow that transitional profile that we had created in the previous session. And also note if we scroll to the end or go to the end using the navigator tools here, the play buttons, just press the end and I'll take you to the ending station. Notice this needs to come down. Okay, so we need a way to control that. Okay, now we already have vertical geometry to make that happen. So how do we get that to work inside of the corridor? Well, I'm going to use something called point controls. If you're familiar, some of our older users with older versions of our products, point controls have been around for quite some time. Give us the ability to override the location of some of our template stuff and make it follow horizontal, vertical geometry, or both, and some other things. So what I'm going to do is I'm going to set up a vertical point control so that we can follow these transitional profiles. Okay, so let me review that geometry real quick so you guys aren't getting lost. I'm going to open up the profile in view number 4 here. So recall, we had our main profile, which was the westbound PGL. That was pretty much used for most of the project, but then we had these transitional profiles for the eastbound side of the road at the beginning and end of the project. So we needed to transition our cross sections there in that area. So this would be one area here at the end, and then the one area at the beginning where we need to raise it up. And then, so let's go ahead and do that. So I'm going to go create my point controls. So I'm going to go up to the edit tools here. You can see I have a tool called create point control. So I'm going to select that. It's going to prompt me to locate my corridor. So I'm going to select my corridor, and then for my stationing, again, it's going to begin at 5:05:10. Okay, that's the beginning of our corridor. Now the transitional profile actually ends somewhere over at like 5:11, so we need to key in 5:11 plus 01.67. Okay, that's the ending of that eastbound PGL transition. Is at that station, 5:11 plus 01.67. So I'm going to key that in, press enter. Okay, and this is just going to be a vertical point control to control the eastbound side of my road. Okay, so I'm going to go through the prompts. Now at this point, it's going to ask me, what point do you want to control on your template? What point do you want to move up or down? Okay, vertically. Well, I want to move the eastbound PGL. Okay, so I have a point on my template And I also have a feature drawn in my 3D view. So we can select it here. See that feature name there? It's called Control Eastbound PGL EOP. That's the point I want to control. I want that point to go up and down vertically to follow this new geometry. Okay, so I can select it here in 3D, could do it in the cross-section view, or I can select it from the little pull-down here. Okay, so if I select it from 3D, and then I set my mode, we want to set my mode to vertical because we just want to control this point vertically. We want it to follow that vertical geometry from in our file, our reference file. So I'm going to left click to accept that. I want to set the control type to linear geometry because we already have geometry created. It's stored inside of our centerline file. So I'm going to set that to linear geometry. And then it's going to prompt me to locate my planar profile element. So at this point, I could just come in here, select my Highway 72 centerline. Now that's in my reference file, so I'm going to select that. Now any profile that's associated to that centerline is going to be available for me to pick as a control. Okay, so it shows us the active profile that we had set for that centerline, but it also shows me my additional profiles that are available that I can use to control this template or this corridor. So I'm going to select the eastbound PGL transition, and then what we're going to do is left click through the prompts. It's going to go ahead and apply that point control to our corridor, and hopefully it raises up that side of my road for me. So now we're at the proper elevation there. Okay, so let's do that same procedure down here at the end of the project. Again, locate our corridor, different station range this time. Okay, so transitional profile for this one is like 536 something. So let me see here, 536 plus 30.51. That's the beginning of this eastbound transitional profile at the end of our project. Okay, so I'm going to key in 536 plus 30.51. Press enter, lock in the value. Left click, stop station 543 plus 00. That's the stop station for our whole project. Press enter, lock in the value. Left click. Give it a description if you feel like it. I'm just going to left click through there. Again, locate the point you want to control. I can grab this from the 3D view. It's the control EP, EB, PG, EOP. Okay, so that's the point we're going to control. You can see that's going to be the same one there. Okay, so I'm just going to select it from the 3D model. Set the mode to vertical. Control type, again, linear geometry. It's going to prompt us to locate the center line. We'll locate that. Now, for this ending part of the project, we're going to select the eastbound profile grade line. This is the end transition, so that's the ending one. And we're just going to left click through the prompts there. And then I'll scroll through the sections and you'll see how that changes. So let me go back to the end here. So down at 543, you can see now we're back down to grade, so we're not way up in the air anymore following that one profile. Okay. Okay, so we got that taken care of. So the profile, the corridor is following the proper profiles now for the entire project. So now the next step is to apply our super elevation, and then we need to handle our pavement widening, or those tapers at the beginning and the end of the project. Okay. So let's go ahead and do our super elevation, apply our super elevation to our corridor, because right now everything is at normal cross slope. You can see on the sections nothing's being super elevated. If you grab the corridor here, you'll notice there's a cross-section navigator tool, this big orange thing with these arrows on it. You can grab that and kind of navigate over to the curve. If you scroll that over and move it into the curve area, you'll notice the cross-sections update and show you what the cross-section looks like in that what would be a full super section. Okay, so you can see right now, pavement's obviously not being super elevated. It's not set up right. Okay, so we need to apply our super elevation that we calculated in the previous steps. So to apply the super elevation to the corridor, we go up to our super elevation panel here. Again, I'm in the corridors tab. Under calculate, go to assign to corridor, locate your super elevation section. So that's our section that we created in our super elevation file. Select that, right click. It's going to prompt you to locate the corridor that you want to assign the super elevation to. We're going to locate our corridor. We're going to select that. And what you're going to see over here, these are the super elevation lanes. So this is the super elevation information from our super elevation file. And then here you're going to see the super elevation points from our template. Okay, so these are the points here in this column that says super elevation. These are the ones that are going to be super elevated, and these are going to be the pivot points that apply to each of the lanes and the super elevation calculations and transitions that you saw in the super elevation file. Okay, so that's how this stuff relates. These are the template points. Remember, we built those lanes based off of the template, so that's how a lot of this stuff is related and works together. Okay, so we'll go ahead and click OK. And it's going to go ahead and apply the super to our corridor. And now in this full super section, you'll see that change. And that should be 8% there. We should be in full super there. Okay, so a way to check that real quick is if we right click in the view here, you'll see we have some temporary dimensions that we can place onto the corridor or into the cross section here. So I'm going to place temporary dimension horizontal. Okay, I'm just going to pick some points on my section here, top points. Okay, and it's going to give me the width and the cross slope between those points that I pick in the cross sectional view. Okay, so we got that going on there. Okay, now those will hold. If we start navigating our sections forwards or backwards, those values will stay in place until we decide to remove those. Okay, so again, to get to that, if you missed it, if I went too quick, just right click. And we have place temporary dimension, you select that. We can also do vertical dimensions as well. So if you need to see some vertical information between maybe the inside edges of where that median is, see what the vertical difference is there, you can pick the vertical temporary dimensions as well. If you want to get rid of temporary dimensions, we'll just say remove them all. Okay, so just simple right click gets you access to some of these other useful tools. You can also locate specific stations if you need to by a data point and keying in a station. So we can select locate station via data point, and we can key in a specific station, maybe 510 plus 00, key that in, left click to accept, or press enter to lock in the value, then left click to accept, and it'll take you to a specific station in the cross-section mode. Okay, so finally getting this model to look like something, we still have another area that we need to address. Stop zooming in and out. So we got this taper area here at the beginning of the project we need to address, and we got the taper at the end as well. I'm going to go ahead and turn off my super elevation file just for clarity purposes here. So I'm going to come over here in my reference file tool and turn off the super elevation just so we can see the plan graphics that I have drawn in my file. Okay, so our plan layout, we've already determined what these tapers are going to be, how these are going to be set up. So this is actually some civil geometry that we have drawn in our plan proposed layout file. Now we're going to utilize this to widen out our corridor. Okay, if I come over to my template here, I'm going to go back to corridors, I'm going to open create template tool. Inside of our template here, have some stuff set up in here to look for feature definition inside of the, actually it's this template here. I have feature definition set up on my template points here. That's not the one. Here, grab the right one. Yeah, so has some feature or some constraints set up here to search for a feature definition called road edge pavement inside. Okay, so the template's going to go and search for some graphics that I have to widen out the corridor. Okay, so I just want to show that real quick so you understand how this is going to work. So what I'm going to do here is I'm going to utilize these graphics with that template that I designed for this project. And we're going to utilize this tool here called Corridor References. So we're going to come in here, we're going to add a corridor reference, and we're going to locate our corridor. And a corridor reference is where we can use some graphics to manipulate our corridor. Okay, so what we want to do is we want our template to be widened out to follow this geometry that I have in this proposed layout file. So I'm going to select this edge, select that geometry. I'm going to zoom down towards the end of the project, and I'm going to select that and select those two pieces of geometry. Okay, so now that I have my geometry selected, I'm going to right click, and it should widen out the corridor to that location horizontally. So it's going to find those graphics, it's going to move the template points and the corridor out to the proper horizontal location. Okay, so but in order for that to work, you have to use this this add corridor reference tool in that context. Now we could also use point controls there as well. You know, we were using this point control tool before to control things or override things vertically. You can also set this for horizontal. You could also do that same type of thing there. Okay, just want to show you a different way to do it. It's a pretty quick and painless way to do it by just adding a corridor reference and selecting a couple little graphics there. Okay, so now we got that taper area taken care of. If we zoom down towards the end here, you'll see we have the ending area, ending taper taken care of, and that's pretty much what our corridor is going to look like on the first pass. Okay. Now you'll notice here the template drop increased quite substantially through here, and the reason for that is because of the design settings or the feature definition that I'm using here. So the feature definition I'm using is called final, and inside of that final feature definition, it's actually increasing or densifying the template drops because there's a curve there. So it's trying to give you a really accurate representation along the curve there. So you don't want to see that. You can just simply go into the standards here, and we could turn that off. Okay, so I used a feature definition called final, and that's going to control a lot of the accuracy and everything that you see in the corridor there. Okay, so you can see that the densify horizontal was turned on to true, so it's really increasing and bumping up the accuracy in that curved area there. So if you don't want it to look like that, we can just toggle that off. Okay, and then reprocess the corridor, and that should bring that accuracy down a little bit. Okay, so just a little tip there in case you don't want to be that accurate with the model. A lot of that accuracy is controlled in the feature definition. So this particular one I used for this project was called final. So I think that's about wraps it up.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.